Alright, so we're going to be talking about graphing linear functions today. I'd like us to be able to get to graphing them on a graphing calculator also, so you guys probably have some experience with that if you had Mr. McMillan or Mr. Carver last year. I know that they like to play with those a lot, so it won't be too much new there for you. And then also we'll kind of start looking at kind of using the equation to kind of make predictions about what the shape will look like, see what the slope and the y-intercept have, what kind of effect they have on the graph itself. So let's go ahead and start off here with part A. We have y equals mx plus b. You guys know this is the slope, right? And this is the y-intercept, correct? The slope is the m. And then these two, the y and the x put together, they're all the points that exist on that line. So the m is the slope, the b is the y-intercept, and the slope, I'm sorry, the x and the y is are all the points, and there's an infinite number of points. So when you write the equation of a line, what two of these turn into numbers? The m does and the b. Those things are always the same on a linear function. The slope never changes, so it's going to be one constant number. The y-intercept never changes, it's going to be one constant number. But the x and the y stay as variables because there are an infinite number of points along that line, and so therefore you have to use variables to represent all the points that exist on the line. Like, for instance, if x was 1, then y would be 5. If x was 0, y would be 3. So there's an infinite number of points there, constantly changing. All right. So let's just jump into some graphing. Once again, this is all review. I know you guys have seen this probably since you've been in 9th grade, but that's okay. It's something they want to make sure everybody's on board with. So we're just going to start graphing. Every one of these examples that I've included kind of have a little twist that sometimes students get snagged up on, so I want to address a few different scenarios. So go ahead and write down your directions in number 1, and we'll start there. All right, so I suggest starting by graphing your y-intercept. So what's our y? Hello. Okay, cool. The spot over. You can probably sit back here behind Leilani. Is Mr. McMillan full?
No.
Oh, all kinds of the issues. All right. Well, welcome to the class. Anyway, so what's our? Well, looking at this equation, guys, what's our y-intercept? -1. So I would say we're going to start there, right? I want to plot that on your y-axis. That's step 1. Yeah. So I'm going to put a dot right there, -1. Oh, -1. I put it at +1. Let me rewrite all that good stuff. -1. Put a dot right there. Now the slope's not a point, but the slope helps you, it gives you the directions to find your next point, right? So this is my rise over run, correct? So that means I'm going to go up 5 and over 3. And where do I start from? From the point I just made, okay? So starting from that y-intercept, I'm going to go up 5 and over 3, and then I can put a second point. So 1, 2, 3, 4, 5. Up 5 and then over 3. And 2 dots is enough to create a straight line, so there's our function. a linear function. All right, let's go ahead and write down number 2. Why do you think I included number 2 as another example? There's a negative, right? There's a negative slope, and we'll see what kind of effect that has on things in a second. That's right. Can I erase what I have? That's correct. And so now there's 2 ways to tell, right? One way is you can just look over here and see if the slope's positive. The other way is you can look at the graphs that slope upwards as you go to the right. That's an increasing function.
It's going upwards towards the left.
Yeah, well, so in the world of math, it's kind of like reading in English. And reading in English, we go from left to right, correct? So in math, we like to think of going from left to right. And so as you're going from left to right, you're going up. Whereas if it was left to right, you were doing that, you'd be going down, right? That would be decreasing. Now, you could read backwards, but you're going to get opposite answers that way. So in math, we like to think of left to right. All right, let's go ahead and do number 2 here. So we've got negative 3/8. My y-intercept is 2. So I'm going to start at 2, right? Now, since my slope is negative, I'm going to circle both of those together, right? The negative, I'm going to let that go to the top. What that means is as I go to the right 8, so I'm still going to go to the right 8 because we like to go from left to right all the time, right? The negative 3, though, that's a negative rise, which really means it's a drop. Okay, so we're going to go down 3 over 8. Okay, now let's go ahead and do that. So over 8, 1, 2, 3, 4, 5, 6, 7, 8. So over 8 and down 3. So 1, 2, 3. So over 8, down 3 puts me like right about here. Okay. Now this is a shortcut for graphing. Okay. Any function you can always graph in another way. The other way to graph any function is just plug numbers in for x and get answers for y and keep doing that until you have enough points to connect the dots and get your picture, okay? So that's a nice, fallback if you need to. But, there's always shortcuts because we want to be able to get things done quickly. All right, so let's pause there and see how you guys are doing. I wonder if I have student practice on. I do. Would you guys do? We're going to. We will. I want to go slowly, just in case some people need some help. So I would like you guys to do number 1 for me really quick. This is a student practice problem. So go ahead and do that. All right. So Madison, where am I going to put my first cell? You do the fraction first? Okay, tell me what you do. Are you feeling a little unsure and you don't want to share out? Make sure you talk. That's okay. I'll come to you next time. All right. Jason. Where's Jason? Oh, hi. What point did you put first? This y-intercept, right? So we put that first. And then we're going to use that fraction. So let's try Sitlali. Hi, Sitlali. Now what? Good. To the right, correct? So up 1 over 5. 1, 2, 3, 4. Oh, I went too far. Okay, that's really straight on. There you go. And that's an increasing function. I'll try to get that. We can talk about negative slopes again for a second. I'll mention that when we get there. All right, so what we're going to talk about now is for 3 through 5. We're going to just look at those ones now. And all of these are missing numbers. They're either missing a y-intercept, or they're missing a rise, or they're missing a run. Okay, or they're missing multiple things. So, let me ask you guys this. Don't write this. This is just for your understanding. What would you add to this in order to keep it exactly the same? 0, right? All right. So in this case, the missing thing is 0, right? How about this? What would you multiply this by to make sure it stays as 3? 1. Okay, so when you're missing a number that's a multiple, it's a what? It's a 1. When you're missing a number that's like an added or a subtracted value, it's a 0. Okay, now, when you're looking over here, I'm missing the number over here, right? Is that an added number or a multiplied number? That's an added number. So when you're missing an added number, what is it? Okay, so there's our first fact. Missing y-intercept is b equals 0. So if you're ever missing a y-intercept, then the b is 0. So if you want, you can just rewrite it. You don't have to. But in this case, then, my y-intercept would be 0. I would go up 2 and over 5. All right. Let's go ahead and take a look at number 4. So in this case, I guess I should have done this. What am I missing here on number 4? We're missing a number again. We're missing the run. Now I know you guys already know what it is, but just I'm going to pretend you don't. So 4 over what is still 4? So it's 1. Okay, so in this case, you can think of that as 4 over 1, right? So y equals 4x minus 1. That's the same thing as saying, okay, 4 over 1, x minus 1. Mind if I skip the graph on it? How many of you guys want to see me graph that one real quick? Anybody? No? Okay.
Wait,
Yep.
so why did you put 1 for the...
So why did I do that? Well, I don't want to change what this is. Because if you change this, then it's not the same line anymore. You agree? So I don't want to change the line. I want to keep it the same. Well, and let me say this now also. All 3 of these problems that we're looking at, 3, 4, and 5, they're all missing one of those 3 things, right? So, but just because they're missing them doesn't mean that there's not a value there. We just don't write the value because, like for this one in number 3, just because there's no y-intercept written, that doesn't mean there's no y-intercept. It just means that it's 0. Okay? Same thing here. Just because there's no run there doesn't mean there's no run. It just means the run's 1. Now, how do you know that? Well, don't you agree that 4 over 1 is the same thing as 4? So I just rewrote this so I can see my run. Does that make sense? So you don't have to rewrite it. But here's the other fact then you want to write down. Ready? If you're missing a rise or a run, they are 1. The reason why those are 1 is because the rise is something you're multiplying, right? And we already said, like, well, 3 times 1 is 3, right? So if the rise is missing, then that's 1. And the run is 1 because 4 over 1 is the same as just 4, right? So if the rise or run are missing, then you can assume that they're 1. Let's go ahead and take a look here at number 5. So go ahead and write down number 5. All right, so what am I missing on number 5? We're missing the rise and the run, right? So in that case, what did I say the rise and run would be if they're missing? They're both 1, so it's rise over run is really 1 over 1 there. Okay? And once again, if you don't mind, I'll skip the graphing just for the sake of time, because it would be kind of repetitive at this point. Now I'm going to have you guys do some more student practice. If you felt like on the last set of graphing, like you're like, I didn't get that quite yet, then I would encourage you to, after you fill in the missing numbers, I would encourage you to actually try graphing it again. And when I go over it, I'll put the answers up for you so you can check the graph. But if you feel like I got this graphing thing good, you just want to fill in the missing numbers, I just want to make sure you guys know what those are. Okay, so there's that. Let's go ahead and take a look at the student practice. So for numbers 2 and 3 only, for numbers 2 and 3, I want you to just rewrite the equation with the missing number. Rewrite the equation with the missing number. And like I said, if you feel like you need more practice with graphing, then go ahead. When I go over it, I will include the graph. So go for it. Amanda, what did you rewrite this as? Are you Deep? D-I-E-P? Is that your last name? Oh, okay. So now I've got 2 in there, because you're Amanda too, right? Okay, cool. No problem. I'll come to you next, Amanda. What's your last name? With a B? Okay. Thank you. All right, so I'm going to graph it. So Amanda Deep, where do we start at? On the y-axis, right? And then we go, so that's number 2. All right, John. Oh, John, right? You're John? What are we missing here in number 3, John?
Number 3, we're missing Y-Intercept.
And what would it be? Cool. All right, and then for those of you guys that wanted to practice here, Sam, where's Sam? Oh, where do we start?
0.
And where do we go?
Up or down 4 over 3.
Since it's negative, we're going to go down 4, right? And then over 3. So that's a decreasing function. All right. Go ahead and look at number 6 and 7 here. So number 6, we're missing a lot of stuff. So these are a little bit different. I'm going to put number here. And here's a note. Anytime you have y equals a number, it's just going to be a horizontal line. Okay? So in this case, we're looking at y equals 2. I'm going to go up 2, and I'm going to draw a horizontal line through 2. Now, I think what's confusing about that is when we think y, what direction do we usually think? Up and down, right? And so I think a lot of people want to graph a vertical line for y equals. But here's why this actually makes sense. Because no matter what point you pick on this line, what's the y value? The y is always 2. Okay? That's why that makes sense. Notice, does x have any effect on what y is? So notice that x is not a part of this equation, right? So no matter what x is, y is always 2. So since x doesn't really matter, y is just a number, okay? So, and you guys could probably imagine what I'm going to say about this one then, right? When you have x equals a number, that will be a vertical line. In other words, no matter what y is, x is always that value. So if I were to graph this, there's x equals 2. You guys agree? And so we're just going to draw a vertical line there. And no matter what value of y we pick, no matter how high or how low we go, x is always 2. Okay? This one, just so you guys know, has an undefined slope. Yeah.
So is y equals 2 undefined?
No. You know what? I'll go back to that. We'll add that note. Thank you for asking. Let's come back to this one, though, real quick, and then I'll go back to the one you were talking about. So you guys know this is our slope formula, right? I'm writing it backwards, but it still works. Right? Well, if I pick 2 points, what do you know about the x's of both of those points? They're both the same, right? They're both 2. And so what am I going to have on the bottom? 2 minus 2 would be 0. You can't have 0 on the bottom. That's a sad case. Like undefined, we say there's no slope. Okay? No, I'll go back to the other one. I'll show you the last one. I should have did that, but I didn't. So I'm going to come back here. Now the y's, it won't be 0 here, right? Because if I pick these 2 points, you see how those would be 2 different y values? So they will have a number on top, but the bottom's going to be 0. And that's undefined. Now let's take a look at the other one.
How's the bottom?
So what's this? These are x values, right? So what's this x value? 2. What's this x value? What?
So don't we like go with the line, like 2, 3, 4, 5, 6?
I'm not sure I understand.
Like on the x-axis, not just 2, right?
Well, since this line is x equals 2, every point, no matter what the y value is, I'll put a question mark there, the x value is always 2, right? So it doesn't matter which point you pick, the x value is always 2, right? So 2 minus 2 would be 0 on the bottom. So when you have a vertical line, no, you don't go over at all. It's just straight up and down. And so the x value never changes. So let's back up. So thanks, Brooklyn, for asking that question. I'm going to come back to y equals 2 because I'd like you guys to write this. So we had this, right? You don't need to rewrite it. You already have it. For this one, if I pick these 2 points, what do I know about these 2 points? They have the same y value. What are their y values? In this case, their x values are different. Like this one over here is a negative x, this one's a positive x. But the y values are the same. They're both up 2, right? So if I plugged in up here on the top, 2 minus 2, what would I get on the top? 0. Now it's okay to have 0 on the top of a fraction. That's actually 0. So we say that this slope is 0. That's a constant function, we call it. Okay? But x equals 0, we say has no slope. And I don't know if this analogy is really the best, but sometimes people are confused, like how is 0 different than none, right? And here's an analogy I came up with, but I'm not too sure if it's a great analogy, but I'll give you an example of how 0 can be nothing but none. Right now I have $0 in my pocket, right? Is that the same thing as saying money doesn't exist? No, right? So slope here is 0, but there is a slope. Vertical, we say slope doesn't exist. There's no slope to that line.
For the other question, that would be on the top or
So it's y equals -3, right? So that's a horizontal line going through -3. And what's our slope? 0. Okay. Let's go ahead and move on to number 8 here. This is an example of how to graph a linear function that's not in y equals mx plus b form. The point here with these ones is that you need to change it into y equals mx plus b form. There's ways to graph it with not doing that, but I'm just going to stick with what kind of works in all circumstances here. And so what we're going to do is we're just going to put it in y equals mx plus b form. Another reason why it's nice to do is because the graphing calculator, which I hope we get to today, if not, no big deal, but we'll try. You have to have it in y equals mx plus b form if you want to graph it. Okay, so it's a good thing to know. Well, let's do it. All right, so the goal here is we want to change to y equals mx plus b, and you're going to do that by getting the y by itself, solving for y. So here's my equation. I've got 4x minus 3y equals 9. So if I want to get y by itself, I'm going to draw a line here. We have an equation on the left side and the right side. What do I want to get rid of on the left side so that the y is by itself? -3. Good. And how would I get rid of that -3? Divide it. You're going to have to divide it. How do you know that? Because it's doing what to the y? Multiplying, right? You do the opposite. So somewhere along the line, we're going to have to divide by a -3. Yeah? Good. We also want to get rid of this 4x, so you're going to subtract that. Okay? So those are two steps. And I do like to do the subtraction before I do the division. So here we go. Minus the 4x. Whoa, hey, how are you?
I'm welcoming back from summer all the math and science teachers.
Oh.
So,
I wish I could take credit for it, but I guess the kid did something too, right? So here we go. Minus the 4x on both sides, right? Now you can't combine these though, right? And so I'm just going to put -4x and the +9 goes there. Uh-oh, I heard some mumbling. You guys got questions for me? Yeah. A little loud? Say that again? Yes, that's the next step. Was there another question? No? Okay. I heard more than one mumble. So now you can't combine these, right? So I put the -4x here, and is that a positive or a negative 9? So I just put +9. That's good. And you could have put 9 minus 4x, but when we look at y equals mx plus b, you can do that, but it just confuses students, I find, when they write it as 9 minus 4x. Anyway. Yeah.
So if there's an x, you'd be able to do it to subtract it.
Oh yeah. So if this was a 9x, yeah, you would combine them.
So since it's 9, just the 4 on that side.
That's correct. So it's like that old thing about combining like terms. All right, and so yes, then next we're gonna divide by -3, and when you do that, you're gonna divide every term by a -3. Now the problem with this particular problem I'm showing you is that this is only one type. It's a common type, but really an equation can be written in a variety of ways. So how you get the y by itself, I'm kind of relying on your algebra skills a little bit there, but I'm here to help if you need it. So these cancel, right? Now double negatives become a positive. And then 9 divided by -3 is negative, right? And I'm not going to graph it, but now it's ready to be graphed, right? You can see your y-intercept, you can see your rise, you can see your run.
Okay, so the question I had after homework. So like, if you have, so it is dividing, but there are additions.
So do numbers 5 and 6. Number 5 is a lot like the one I just did. Number 6 is different. The goal is get it in y equals mx plus b form. Okay? Just here I'm trusting you as little birds to fly forth from my hand and use your algebra skills and discover how to do that one. But the goal is get it in y equals mx plus b form, right? So, and you guys can kind of check your answer here. So for this one, you would add 3x on both sides first. And then you would divide everything by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. For this one, what would you guys do first?
Multiply the 5.
Good. Distribute the 5, multiply it in, right? So that would be 5x minus 10. And then what would we do? Divide by 2. That would, we're trying to get that y by itself, and at the same time, get that thing into slope-intercept form. Y equals mx plus b form. All right, guys. I'll see you mañana.